everybody, this is our liquid-liquid extraction experiment. Through the extraction column, the goal is to purify the desired species, kerosene, the raffinate, from the undesired species, acetic acid, the solute, via a solvent extraction with water. The main objectives of the experiment we conducted were to determine K, the distribution coefficient, the number of theoretical equilibrium stages, the height of the transfer units, and to construct a P and ID diagram. Now we will go into the methods and procedures behind this process, but before we can do that, the safety concerns that are inherent with this process must be addressed. Apply gloves and goggles to prevent spill hazards. The three species utilized were kerosene, water, and acetic acid. The first step is to add appropriate amounts of kerosene, then acetic acid to the organic front tank and stir the mixture for a few seconds. Second, once the mixture settles, take a sample of this to determine the appropriate starting density and adjust if necessary. Third, add appropriate amounts of water to the aqueous back tank. Fourth, turn on the two air valves. Fifth, turn the air flow rate valves on the wall. Sixth, turn the flow rate valves for the heavy and light phase to fill up the column. Seventh, once the column is filled up, adjust the heavy phase valve to keep the phase separation between the two pipes. Eighth, turn on the agitator at the top of the column to make the data a function of the agitation rate. Ninth, continue adjusting the heavy phase valve and collect samples over time from the raffinate and extract tubes. 10th, determine the density of the raffinate, kerosene, with the density meter. 11th, determine the conductivity of the extract, water and acetic acid, with the conductivity meter. 12th, once data collection is done after about 30 to 45 minutes, turn off the agitator and the rest of the equipment. 13th, clean up any used equipment. Lastly, make sure organic waste is properly disposed. So, if all of these safety measures, methods, procedures, and objectives are performed and utilized accordingly, a fully functional and comprehensive liquid-liquid extraction experiment will be simulated. Most importantly, one will learn the proper methods to optimize the separation, and a nearly pure kerosene product will be generated and ready to hit the market for immediate profit.